Welcome to our series of tutorials on PanMesh. In this example, I am going to demonstrate how to create a region with a hole, or alternatively a region or a reservoir model with a concave boundary. And this can be done. We'll start again as usual with the simple example model. I'll click on well reservoir and fluid description, numerical model, and as usual I will create the basic square model, and let's try and create a model here which has, for example, a hole, a square hole in this region here. So in order to do that, I will break this square reservoir into a more detailed network of regions. And I'll do that by drawing a straight line here parallel to the east-west axis. I can do that by clicking. There's my line, and now if I press on shift, the line automatically becomes parallel to east-west, and I release, and I have created a second region. I do this again, release. Now what I do is I create the square which I want to remove. Do that by again pressing shift. I've created, more appropriately, a rectangle, and now the final steps is I must just connect these points to the outer boundary, and this is for reasons of the mesh generation algorithms. And there we have a lattice or network of regions. To remove this region here, I simply have to click on select. I go to the region, I can see it highlighted, and I right click, and there we see that the region has been removed. Before running this model to confirm the hole has been created, I must finish it. If I click on model check, I will see that I have not entered the perforation data, so I go to well configuration, and I will enter a partial completion of, we'll say, 20 feet. I go back to model check. Now the model is complete, so I only need to click on OK, and then go to simulation, PanMesh new run, and I see that the model with the hole is clearly being created. I'll run the simulation. In this case, from the derivative, we can't really see the effect of the hole, but we can perhaps investigate a little bit further by looking at the pressure transient, or the radius of investigation, and we can see as the radius of investigation reaches the hole, it moves around it, engulfs it, and carries on. And you can see why it doesn't have much of an effect on the derivative in this case. But of course that isn't always the case.